morning, class. We're going to be talking on cost behavior graphs today. And to begin with, we're going to talk about mixed costs. As you can see, mixed costs is this black line right here, and it is composed of the fixed cost line and the variable cost line as a sum. The fixed cost is always going to be constant, and variable cost is always going to depend on the volume, which results in the black line. Does that make sense to everybody? Julia?
I don't get it.
Yeah.
Do we have any real-world examples of these graphs?
Yeah, I think that'd be very helpful.
Yeah, I think I could think of some examples for you guys. Let's go outside and see some stuff.
Man, that clothing store was crazy.
Yeah, we got some nice clothes.
I know.
All right, Sam, our first example is fixed costs. And I know you asked about mixed, but fixed costs is one aspect we have to consider for mixed costs. So fixed costs is just a straight line that stays at a constant cost through a whole period of time. So no matter if I'm at the very first period of time or another 10 months out or 2 years out, it's always going to be the same cost no matter where you are. Does that make sense?
Yeah, it makes sense to me.
Okay. And that vertical distance would be what would represent a y-axis. So if it was $0 on the ground and maybe up to 10 grand up here, it'd always be 10 grand for that whole time. Does that make sense?
Yeah.
Okay. So we just did fixed costs, but if you see this railing, this is a perfect representation of what mixed costs are. So we said back there that fixed cost is a constant line. So imagine from the ground up to this point, this is what represents our fixed costs. That's 10 grand that we had. But from this point at the beginning of the rail, all the way up, this is representing our variable costs. So when you add fixed costs and variable costs together, this is going to be our mixed cost, which is just a shifted variable cost based on your fixed costs. Ben, Sam, seem good?
So mixed cost is variable cost plus fixed cost.
Yes.
I got it. Yeah.
Cool.
I think I got it too.
So mixed costs are making sense to me, but what about stepwise costs? Could you explain that a little better?
Yeah, I think there's a good example in the library. Let's just take some steps over here and we'll go. So the staircase is an example of what is a stepwise function. For each step, it represents a fixed relevant range with volume. And as it changes from a step, it decreases for a proportional amount of cost. But also notice that this is in a downward direction. It can also increase as well.
Wait, so then what about curvilinear?
Well, here we have another example I can show you. So Julia, curvilinear costs always increase with the volume, but it's at a non-constant rate. So as you can see with the wire that they are holding up, it's always increasing at different rates. At the beginning it's fairly low, but then it spikes up. But as you can see, as Sam drops it down, we can never have the graph decrease as it shows near the x-axis. So we have to always make sure it's brought up and it's always increasing.
So it increases but at a non-constant rate? I think I get it.
So is that making sense to everyone? I gave you guys some different examples, but hopefully you guys have a good understanding now.
Yeah, I think I got it.
Yeah, that makes sense.
I think I'm ready for the test.
Awesome. Well, hopefully you guys are as big of a fan of cost behavior graphs as I am. Worth a shot.